Okay, so for this section, we're going to talk about antiderivatives. Okay, so we're taking everything we learned in VCal 1 and we are going backwards. So again, make sure you have those notes printed out in front of you because I'm going to refer to them as I do these examples. Okay, so the process of going backwards, me giving you the derivative and you going backwards to find the original function is called antidifferentiation, okay, or integration. That's probably what I'll refer to it as. Okay, so make sure you read through those notes and then those basic integration rules. Have them out in front of you as we do this. Okay, so first one, integral of 3 dx. Now, I do want to say this. Anytime you see this long kind of stretched out s, that's your integral sign that's saying, hey, go backwards. And it always comes with a d something, and that tells you what your dummy variable is. So if it's dx, I know I'm integrating with respect to x, okay? If it was a dy, which we'll see later on in the second half of the semester, it'll be integrating with respect to y. Okay, but see, 3 is just a constant, so this goes with your integration rules. Number 1, to integrate a constant, all you have to do is add an x on. So the integral of 3 would be 3x, and then we always put that plus c on there, and I put that in the notes, and we call that the constant of integration, saying, hey, there might have been a number here, some, plus 5 or minus 2/7 or whatever. Because if you were to check your answer, you can check it by taking the derivative and seeing if the derivative of this gets you right back here. Well, the derivative of 3x is 3, and the derivative of any constant is 0, so I do get right back there. The nice thing about this is you can always check your answer. All right, so number 2, integral of negative 1/2 dx. It's another just plain old constant integration. Whenever you integrate a constant, all you have to do is add on your x, and I put an x on it because these are dx's. If they were dy's, I'd put a y on there, and don't forget your plus c for all these. Okay, so those are super easy, integrating just a constant. Let's do some where we don't have just a constant. Okay, all right, like this one, integral of 3x dx. Okay, so now we start with our basic power rule. You are going to use this rule for every lesson, so make sure you get it down. All right, so let's come underneath. The x has a first power on it already. So to integrate, all you do is you add 1 to the power, and then you're going to divide by the new number that you get. Well, 1 plus 1 is 2, so I'm going to divide this by 2. So my answer would be 3/2 x, and then again, I need my plus c. Okay, so add 1 to it, divide by the new power. So the integral of 4x squared dx. Okay, so come underneath it with my 4x squared. Add 1 to it, and I get 3. So now divide by 3. So 4/3 doesn't reduce, so I'm left with 4/3 x to the third plus c. Now again, you can check these. Okay, if you want to see if you did it right, take the derivative and see if you get back to where you started. Okay. All right, then I gave you a note. Any x's that are on the bottom or any radicals you want to rewrite before you use that power rule. So let's see how we do that. Integral of 1 over x cubed dx. Okay, so anytime your x is on the bottom, all right, what you want to do is bring it to the top. Well, we remember that when I pick up this x cubed, all right, on the bottom, and if I move it across that fraction bar, what happens to the exponent? It changes to a negative. Okay, so you can't do anything with them on the bottom. What you want to do is bring them to the top. All right, so again, here we go. Ready to start. I'm going to add 1 to it. What do you get if you add negative 3 plus 1? You get negative 2, so that's what I divide by. So my answer would be a negative 1/2 x to the negative 2 plus c. Now that answer is not okay with me because we know in math you can't leave negative exponents. Okay, you need to fix them. So leave the negative 1 on top, and then down there with the 2, drop that x, and then you have your plus c. Okay, so always fix negative exponents. Fractions, we don't want to make fractions hard, and I know sometimes people make fractions hard, but don't. All right, so we know square root of x would just be x to the 1/2 power. Rewrite it. Okay, so now we're ready to use our power rule. Here's what you don't want to do, okay? You don't want to do 1 plus 1 because one's a fraction, one's a not. So anytime you do have that fraction, match it. So instead of saying plus 1, say, all right, well, plus 2 over 2, okay? Whatever the denominator is, add that number over itself because 2 over 2 reduces to 1. That's just an easier way to put it, okay? So if I add 1 to it, I would be adding 2 over 2, and I would get 3 over 2. Again, this is what you don't want to do. You don't want to say divided by 3 over 2. Okay? If it's a whole number, no big deal. But if it's a fraction, you don't want to divide by it. Dividing by 3 over 2 is the same as multiplying by the reciprocal, 2 over 3. Fractions are a little bit easier to deal with if we look at them that way. So we get 2/3 x to the 3/2 plus c. Okay, so again, be careful when you add that 1, make it number over number, and then don't say divided by 3 over 2. Dividing by 3 over 2 is the same as multiplying by 2 over 3. Just makes it a little bit easier, especially like when you got one like number 7. Okay, integral of 2 over cube root of x dx. Okay, so the first thing I have to do is rewrite it. So that would be 2x to the negative 1/3 dx, because what I had to do was change that cube root of x to x to the 1/3, and then it was on the bottom. I had to bring it top, and it became negative. All right, so I want to add 1 to it. So if the denominator is a 3, now I'm going to say plus 3 over 3. So what new power do I get? What's a negative 1/3 plus 3 over 3? I would end up with 2/3, right? And so instead of dividing by 2/3, dividing by 2/3 is the same as multiplying by 3/2. Okay. And then if I get ready to simplify it, the 2's knock out. So I'm left with 3x to the 2/3 plus c. Again, check this if you want to multiply really quick. Take the derivative. 2/3 times 3 would just be 2x, and then I subtract it and I get negative 1/3, and so I know I did it right. All right, sometimes you can see more than one term. Don't let the parentheses throw you off. I usually just ignore them. I got 2 terms, and so what I want to do is, I guess I don't need that there. What I want to do is integrate them both separately. So again, that already has a 1. So if I add 1 to it, I would get a new power of 2. And then how do you integrate just a constant? Those are the first 2 we did. We just stick on an x. So this one would be 1/2 x squared plus 2x. And then my plus c. Okay. A couple more. Let's do another one of those. Integral of 3x to the 4th minus 5x squared minus 4 over x squared dx. Okay. First thing we'll do is come underneath it, get ready to rewrite it. So if I bring that up, that's to the negative 2 power. All right, so 3 terms for each one. Add 1 to it, divide by the new power. So add 1 to it, now divide by 5. Add 1 to it, now divide by 3. All right, what do you get here? Add 1 to it, you get negative 1. So let's divide by negative 1. So we would be left with 3/5 x to the 5th minus 5/3 x cubed. All right, be careful with your signs. This negative and this negative switch to a positive, and 4 divided by 1 would just be 4x to the negative 1 plus c. If you're looking at that, is that answer okay? Absolutely not. What's wrong with it? You cannot have that x to that negative 1 power. So fix that last one. So these first 2 terms are fine. Leave the 4, but drop that x to the bottom. Okay. All right, so a couple more left. All right, big important note. It says when you have one term in the denominator, put that one term under each term in the numerator and simplify before you integrate. These are one of my favorite problems. Make sure you can do this. Expect to see this from me on quizzes and midterm. Whenever you have one term on the bottom, okay, what you want to do is divide it out. Everybody gets divided by 2x cubed. Okay. and simplify that. So we would be left with 5x squared minus 3 halves. Alright, so if you subtract it, remember when you're dividing, you subtract those exponents, you would get x to the negative 2. And over here, you would get 8 divided by 2 is 4, and you can't integrate with that x on the bottom, bring it to the top with that negative 3. Alright, simplify it first. Now, add 1 to it, divide by the new power. Add 1 to it, divide by the new power. Add 1 to it, divide by the new power. So we would get 5/3 x cubed. Alright, those two are going to switch it to a positive. 3 halves x to the negative 1. And this makes it a negative 2 x to the negative 2 plus c. So let's fix it real quick. 5/3 x cubed plus 3 over 2x minus 2 over x squared plus c. Alright, I'm going to do the last two on a separate video. Okay, so two more really quick ones. I'm going to try to do them all on this video. Alright, integral of x plus 1 over the square root of x dx. So again, one term on the bottom, we're going to square root of x would be x to the 1/2. So split it up, and now simplify it. So remember, when you're dividing, you subtract those exponents. So 1 minus a half becomes x to the 1/2. And then here, I just need to bring it to the top. Okay, so fractions. Add 1 to it, but we're going to write 2 over 2. So what new power do I get? I get 3 over 2, and dividing by 3 over 2 is the same as multiplying by 2 over 3. Add 1 to it here. So what new power do I get? I get 1 over 2, and dividing by 1 over 2 is the same as multiplying by 2 over 1. So I would get 2/3 x to the 3 halves plus 2 x to the 1/2 plus c. Okay, don't make fractions hard. And then the very last one, it says if you don't have a power, 3x squared. Alright, if you don't have a power on the parenthesis, meaning, you know, it's a first power right here, understood first power, just distribute real quick. We would get 6x to the 3rd plus 10x squared. And now we can very quickly add 1 to it, divide by the new power, add 1 to it, divide by the new power. So in this one, reduce that 6 over 4 to 3 over 2, x to the 4th, right? Reduce it to 3 over 2. And then this one doesn't reduce, 10/3 x to the 3rd plus c. Okay,